My name is Georgos Siganos, and My name is Georgos Siganos, and I'm a PhD student at the University of California, Riverside. I'm really excited to present my work here at NANOG. I just hope my excitement doesn't mess up with my presentation. So today I'm going to talk about our tool Nemecis and present a brief analysis on the Internet Routing Registries and on the quality of the information they contain. So basically, the Internet Routing Registries were established as a means to improve the cooperation between autonomous systems. And the vision was to have a stable, analyzable Internet using the Internet Routing Registries. Basically, they allow an autonomous system to register its policy, which means basically register what the neighbors of the AS are and what they import from their neighbors and what they export to their neighbors, okay? So in reality, though, the IRR as implemented today, they just store these policies as clear text, okay? So in the registries, there don't exist any consistency checks. So we don't know which registries are correct or which registrations are not correct and which registrations are not fresh. And to the best of our knowledge, there does not exist a tool that can analyze these policies. So our goal is to provide a systematic approach and a tool to analyze this policy and be able to identify the policies that are correct and fresh. So in order to do this, we have two phases. In the first phase, we check for errors. In the second phase, we check for freshness using the external source of data like BGP routing tables. And our tool consists of two parts. We have the backend that we use the Postgres database to store the policies and do all the analysis. And we have a web-based front end that you can use to query our database and find out possible errors that we found in the IRR. And the results I'm going to present today are from June 22, 2003. So, today there exist over 50 registries worldwide. Some of them are regional, like RIPE in Europe, RADB in the America, APNIC in the Asia and Pacific regions, and some of them are provider-based. So basically, an AS maintains its own registry in order to publish its policy information and the information of their customers. So the biggest registry of all is RIPE, which has over 6,300 autonomous systems that actually register import and export filters. We have a little bit over 2,000 ASs for both RIPE, for both RADB and APNIC, and we just have 1,000 ASs for the rest. It's worth noting here that, on average, an AES in RIPE registers 12 neighbors, that has links with 12 neighbors, while in RADB, they only register 6. In APNIC, they just register 3, and for the rest of the registers, the average is 6. Of course, the important thing is not how many AESs register their policy at some point in the past, but how many they maintain their policy correct and up to date. So the first test we can check is both peers register each other. So in this simple example that we have here, we have the policy of AS1. So AS1 registers that has a link with AS2. So what we want to find out is if we have a registration for a link between AS1 and AS2, do we have the reverse direction? So does AS2 register that it has a link with AS1? So we compute the percentage of the links that exist in both directions per registry, and we find out that for 49% of the links in RIPE, there exists the reverse direction, while for RADB, the percentage is only 14%, for APNIC is even lower, it's 6%, and for the rest, it's 16%. Now, in the case when both directions exist, we want to check if the filters they register is the same. So again, in our simple example, if AS1 registers that from AS2 it will import B, does AS2 register that it will export to AS1B? And again, we compute this per registry. And we find out that for RIPE, 49% of these cases, they use the same filter. For RADB, it's 40%. For APNIC, it's 38%. And for the rest of them, it's 56%. So the next thing we want to do is check the policy of the AES in isolation. So is the policy as registered correct? In order to do this, we have to match what the AES imports and what the AES exports. So in this example here, in the small example, we have that this particular AES exports A, B, and C. So from where does it import them? How does it know this A, B, and C, okay? So C originates from within the AES, A comes from the left link, B comes from the right link. So basically we want to compute, from the low level policy, we want to compute the link level policy and be able to check if the policy is complete and also accurate. So the tests for consistent that we use we have two different kinds of tests. The first one, we call them policy-based tests, and basically we check the correctness of the policy, and that means that we want to see if the import and export are consistent and if the link level policy is symmetric. And then we check the freshness of the policy. And by freshness, and basically we use the BGP routing tables to check the freshness, and we require that all peers of an AES as found in BGP must be registered in IRR, and also the high-level policy of an AES should be the same in both BGP and in IRR. Basically, there are heuristics that can extract the high-level policy from BGP paths, and we can do the same thing from IRR. So if in the BGP paths you have a particular AES as your upstream, we expect to find the same thing in IRR. So if any of these tests fails, then we consider that this registration is not correct. Okay? So these are our results. So for the left-hand plot, we have the percentage of the AESs that pass the policy-based test. So for right, we have that 80% of the AES pass the policy-based test. For RADB, it's 77%. For APNIC is 84%, and for the rest is 72%. Here we should note that there are some requirements for our approach to work correctly. In most of the cases, the requirements are met, but there are very few AESs in which, even though they register correctly the policy, we find them as incorrect. Now, when we also add the BGP test to check if the policy is fresh, the percentages drop dramatically, okay? So we have 34% of the AES in RIPE that also are fresh. In RADP, the percentage is only 15%. It's 25% in APNIC and 14% for the rest. And also remember that our tests are very strict. So no matter if an AES registers 1,000 peers, if it misses one peer in the BGP, then we consider the AES to contain not valid policy. So this is a snapshot of our web-based interface. So basically, we group all the RPSL source code based on the AES. And in the first tab, you can see this, you can have links for the source code, so you can go and click them and find out what is the source code in RPSL format. The next tab, the external warnings, are what the AES register versus what its neighbors register. So for example, if you register a link that it doesn't exist, we put it there. Then we have the internal warnings. You export something that we don't know from where you import it, so we also have it there as a warning. Yeah. And then we have the link level policy, where basically we have the full correlation between the import and the exports. So our conclusions. So to the best of our knowledge, this is the first effort to quantify the consistency of IRR. We find out that RIPE is the best registry overall, with over 2,100 AESs passing all the tests that we have. And here we have to say that, in RADP, for example, and in APNIC, the total number of AESs that are registered are less than this number, and a lot of useful information exists in the registries. We are actively seeking feedback and collaboration from the industry. How can we use our tool to help the ISPs? Do you think our tool is useful or not? And please go and check our tool at the following location: http://era.cs.ucr.edu port 8080/Nemesis. Unfortunately, I'm an Apple user, so I didn't pay attention to the Windows World. So if you are using Internet Explorer and you try to retrieve the policy of an AES, it will generate an error, so you just have to go back and boost the pattern again in order to get the policy. Or you can browse the registries. And that's all.
Have you had anyone ask you if they have private data well, if they have private data, not in the public IRR, and would you be willing to run your tool on their private data?
Yeah, of course. And also, even though I don't have my tool online now so that you can download it, I plan to put it the next few weeks.
So you plan to put your tool online and ISPs could contact you and
That's the purpose
volunteer.
of my talk here, so that people know that the tool I developed and check to see, if they like it.
So here's a free tool, guys. Talk to him. He'd like some feedback. If he gives you some good information, it'll help him out in his studies. But again, another free tool that might give you some indication if you're using an